Okay, so here we go with the videos for section 4 point, or video for section 4.1 classifying triangles. Um, so our goal of this section is just really to review stuff you've learned in previous math classes. There really isn't much new here. A little bit of algebras mixed in here or there, but for the most part, this is all review. So first, our first goal for the section is to, or we've measured and classified angles before. Now we're gonna do the same thing with triangles. Okay, so measure and classify triangles. So here we go. Definitions. Recall that a triangle is a three-sided polygon. Triangle ABC, written ABC, has parts that are named using A, B, and C. The sides of triangle ABC are the segments, so AB, BC, and AC, or CA, whatever you want to call it. The vertices are the corners, so A, B, and C. And the angles are angle BAC, ACB, and BCA. Excuse me, or you could use the single letter names here because there's no confusion. And part of the key is that triangles can be named two different ways, by their angles and their sides. And a lot of times we do both at the same time. So we got to classify the triangles based upon their angles and sides. And another thing is this too, it's important to recognize, is that all triangles have at least two acute angles. Okay, but it's the third angle that's used to classify the triangle. So not the first, not the second, but the third angle after you get rid of the two acutes. So first of all, acute triangle. All three angles are acute. So your first two be acute and then the third one as well. Equiangular, we'll come back to this, but it's going to be three acute angles. Three congruent, excuse me, acute angles. It is not equal angular, it's equiangular, E-Q-U-I-A-N-G-U-L-A-R. Obtuse means you have one obtuse angle, so you have one angle bigger than 90 degrees. Even though the other two are smaller than 90, they're acute, but the one's bigger. And then a right triangle, these two are acute angles, and you got one right angle left over. So first example here is to classify the type of triangle we have as acute, equiangular, obtuse, or right. And in this case here, you can see all three of the angles are acute, and they're all equal. So you actually could do two. You could do acute or equiangular. Either one of those would work. Most specifically is equiangular, but you could also call it acute. The next triangle, we're looking at this again, ignore the two acute angles. We got to classify it as acute, equiangular, obtuse, or right. In this case, hopefully it's pretty obvious that the biggest angle is obtuse, so this is an obtuse triangle. We can also have bigger drawn triangles like X, Y, Z, and we have to explain what type of triangles those are and classify them. So hopefully this is pretty obvious to you, but if it's not, we're going to go through and take a look at it real quick. So I'm looking at this triangle here, the big overall XYZ. Well, if I look at that, I've already got two angles, 50 and 40. So those are two acute angles. So the question is obviously going to be, what kind of angle is this leftover angle? If that leftover angle is obtuse, it's obtuse. If it's acute, it's acute. If it's right, it's right. Obviously not equiangular because 40 and 50 aren't the same. So we have those two. Oh, well, by the angle addition postulate, I can add them together. So 50 plus 40 is 90. So this is a right triangle because the last angle was a right angle. So hopefully pretty straightforward. All right, next set of ways to classify triangles. You can classify them by their side lengths. Okay, and the side lengths, it isn't like the other one where you have like two certain types. This is just they are what they are. So if all three sides are the same, it's equilateral. And that is equilateral. It's still not equal. It's EQUI, but lateral means side. So sides or equilateral. Isosceles. Now this is something that might be different from your previous math classes you've taken, but for us, isosceles is at least two sides congruent, not only two sides congruent. And again, I'm pretty generous about spelling, so if you misspell isosceles, I'm not going to freak out at you, but it is isosceles, and not isosceles, and not some kind of crazy weird spelling of that. ISOSCELES. And then scaling is no congruent sides. And one of the things to make note of is a triangle that is equilateral is also isosceles. Okay, because since a triangle has at least two congruent sides, it'd be isosceles. If you've got three, 3 is at least 2. So this drawing here, we got to classify out the triangle. We got a big triangle here. We got triangle. Oh, I'm sorry. Yeah, we're going to do WVY, excuse me. So we know that Y is the midpoint of VX. And I'm sorry, this kind of, the font's all over the place. And WY is 3 units. So 3 is WY. That side there. Okay. Which means when I look at this, VW is 4.5. This is 3. So it can't be equilateral. So it can only be isosceles or scalene because I'm looking at this figure here. V W Y. So I already know this guy's 3 for this side. I know this one's 4.5. And then they tell us in the given as well that Y is the midpoint of VX. That means then that this has to be bisected, or those are going to have to be congruent, however you want to think of it. So that means that VY has to be half of 8.4, which is 4.2. So little triangle VWY, 4.5, 3, and 4.2. Oh, it is going to have to be scalene. None of the sides are the same. Next type of problem is an algebra one. In this problem here, it says find the measures of the sides of an isosceles triangle, KLM with base KL. Now, one of the things I just realized now that I've gone through this, and I don't want to restart it, is I forgot to mention way back in this drawing here, when we talked about, oops, I skipped too far back, that the non-congruent side of an isosceles triangle is called the base. Okay. So our base then for our isosceles triangle is this side right there. Okay, because those two sides are marked congruent, that's the base right there. All right, so our example then is to find the missing side lengths, knowing that base KL is the base. So what that means for us in the drawing is if KL is the base, that means that KM and LM have to be the congruent sides. Those two do. So in order for them to be congruent, that means that 4D minus 13 has to be 12 minus D. Okay. So now just, I don't know, add a D to both sides. Cancel it off. Add 13 with the 13 over here. We get 5D is 25. Divide by 5. D is 5. Okay, so we have to solve for D first before we can do anything. Then plug it back in. 20 minus 13 is 7. 12 minus 5 is 7. That's good. Those two should be the same. And then 5 plus 6 is 11. So 7, 7, 11. All right. Now, next is your homework. Okay. So for this problem here, we know it's an equilateral triangle. So it says find x and the measure of each side of an equilateral triangle ABC if AB is 6x minus 8, BC is 7 minus x, and AC equals 13 minus x. So there you go. So that's your homework for the night. If you got any questions at all, please just come on in the morning before, the morning of, and we will go over anything you have questions on. Thanks.